Fibonacci.
So my question was,
Wow.
what if they entered a negative number? Would it cause an error?
You know, there's only one way to find out, Cindy Lou. Let's do it. All right.
Just get stuff.
Yeah, I'm not sure what it's going to do. We didn't account. Oh, wait. Now I have to like read up on like what negative numbers technically do to Fibonacci. That looks pretty insanely huge too, though, right? Not sure which output I'm looking at.
Well, some of the code type.
This is what we call big data, folks.
So it says enter an integer, and enter -1. It says that number 1 is, if n equals 1, it'll go through that, or n equals 2, f
Right.
is 1. Else, whole equals 1, whole equals 2. So where's our user inputting it?
It's the n.
I in range
2
2
to
to the negative number, the negative 1.
Well, that of course is going to count down from 2.
Right.
I'm not sure what functionally. I mean, I think that it has. Yeah. So they're saying here that this formula is valid for any values greater than 2. Otherwise, 0 is 0, 1 is 1, 2 is 1. And I don't know if they have anything in here about negative numbers.
That was pretty interesting where that came out from.
Yeah.
Yeah, I wasn't expecting that.
Yeah. And you know, how would you handle that? You could just put in another statement that said if n is less than 1 or 0, right? So you could actually put in a provision there, if n equals 0, it's 0, right? Because that's actually what the formula is. If n is less than 0, put an error message on the screen. That's what I would do.
Yeah.
So yeah, I think it's a fascinating little exercise, though. And holy cow, I didn't realize it could just generate numbers that huge without crashing. Yeah. Now, with some languages, they hit limits in terms of how big the numbers are that are allowed that are generated. You see what people are using Python for doing this kind of work? Yeah. All right. Do you guys need a short break?
I was just thinking yesterday.
Yeah. All right. Let's take a short break and we'll come back and finish the rest. Okay. We're going to move on to exercise 5.7. And this one says write a function, and they give you the name of it, count words, that returns a count of all words in the string. Okay, so apparently you're going to set up a variable called string. Words are separated by spaces. For example, if you pass into that method, Mary had a little lamb, it should return 5. Okay, so functionally this is what we have to try to accomplish. I'm actually going to go ahead and copy all that over. And since we're going to create another new program here, create a new program, do a save as immediately. This is exercise 5.7. So 5.7 was it count words, however you want to name it. I'm going to paste the instructions in here, and in fact I'm going to make sure they're in the comment section for easy retrieval. Meanwhile, I'm going to look at my cheat sheet here. Yes, I admit it. This is exercise 5.7. And in this particular exercise, you know, we're at this point in chapter 5. Okay, so kind of like a mini Python course. When you got to chapter 5, they introduced to you the concept, several different concepts. So the one thing is now we have loops under our belt. We have conditional statements. So if then else, you know, that whole approach. But they also are teaching methods in this chapter. And the chapter is really more about methods than anything else. So in other words, to create a named block of code, which they dictated what it should be called count words. And then if you're writing a method, then you need a main method in order to drive that method. So we're going to begin by just creating our main method. So let's go ahead and do that. So right up here at the top, I'm just going to define main, put in parens, and a colon. So this is where the main body of our program is going to be, where we're going to do this stuff. I'm going to create a couple of blank lines there, and then I'm going to just start, actually a bunch of blank lines. And at the very bottom, we want our program to execute that main function, so I'm just going to put in a call to do that. Otherwise, the program's not going to run, right?
Yeah.
And that's one thing you learn the hard way pretty quick,
Why
right?
didn't it work? Why not?
Well, you got to call it.
Yeah.
Yeah. That's a classic programming problem. Now they also gave us a pre-named method. Heck, they even got the definition thing in there. Why don't we just copy paste that? Why type when you don't have to? I was a fan of that. So we're just going to put that in. We're going to put a colon at the end, so we have the name. All right. We need the algorithm that's going to do this. Now that's kind of like a whole separate issue. In terms of the main program body, they do want you to prompt the user for a string. So I'm going to actually create a variable just called input. Yeah, that's probably good. Input str. And then I'll just call input. I don't have to convert this, right, because we're pulling a string in and it'll be a string, so there's nothing we have to change or format to any number format like we've been doing. And you just prompt your user to do what you want them to do. And then the next thing that we want to do is we want to put the result on the screen. So it should just return basically the number of words. Now I think it's kind of lame to just say, like if Mary had a little lamb and just 5 pops up on the screen, we should probably say something with it. So let's put in a print statement so that we're friendly to our users or useful to our users. You can just say the string contains, comma, well, we got to put something here, I'm not sure what it is yet, and number of words. Now what's going to go in the question mark spot is actually the return statement from the method that we're about to type up. And really what we're going to do is we're going to call that method, which is called count words with parentheses, and then inside what we're going to pass to it is what we just grabbed from our user. So pretty simple setup really, but now at least we're set up to run it. Okay, we're going to grab it from the user, we're going to insert that into the method, the method's going to do whatever it does, and then it's going to spit back the result. All right, first thing we're going to do inside the method is we're going to do this. We're going to take the string that's being passed. So see, it's expecting to receive a string, and we're sending it one from here. So the first thing I'll do is I'll set up another variable to hold the string so I can work with it. And what it's going to do to that is we're going to run the strip command or strip method on it. Does anybody remember what that one does?
Doesn't it? Oh, go ahead.
Yeah. Go ahead.
Well, I'm guessing what removes
It removes, what is it stripping out though?
I'm sorry?
What is it stripping out? It's stripping something out. Is it removing the spaces? Now if I remove the spaces, then I don't know what to count. Is that what it's removing? What might it remove? Yeah, punctuation. So in special characters and things like that. So like if I had like an apostrophe in there, it would remove that. Or a period at the end or something, or a dash or something. So that helps to just kind of sanitize the text a little bit. Next thing that we're going to do is we're going to set a provision. Like what if, we got somebody really smart on our hands or think they're smart. And we're going to check to see, did they pass us an empty string? All right. So if they pass us an empty string, you know what? Let's just return a 0 and get the heck out of here. right? I don't have to count anything, right? There's nothing to count, right? Otherwise, let's take and create a variable called count and preset it to 1. So we're going to start with the assumption that if it's not empty, there's at least one word. See the thinking? Okay, so if the string is empty, we turn 0. Otherwise, let's keep moving on. The count is set to 1, and now we have to do kind of our processing. And the processing that we have to do here is going to operate in a loop. And what's beautiful about Python is it has all these little automatic mechanisms for automatically looping through structured content. Strings, if you think about them really carefully, are collections of characters. So really, a string is an array of characters, or a list. You know, in Python we call them lists. And that's really what we're going to do is we're going to cycle through on a character level through the loop. So we're going to type a for loop to do that. I think that's probably the best structure for it. So for each character inside of the string, we're going to do the following. First, we're going to see if that character is a space. If it is, and this might be a little backwards now, you might say, oh wait, so if it's a space, that implies a word follows, right? Okay, so we're going to add to the count. We're going to increase the count by 1. We're going to say count equals count plus 1. Why would you count the spaces and not the words? Okay, think about it like this. A word can have various numbers of characters. You can have 1 character, it can have 20, whatever, you know, hopefully not a Fibonacci amount. So really, if we preset the count to 1 before we go into the loop, we already know it's not an empty string, so we already know that there's a word there. So think of the logic of this. Then the loop operates. It goes through every character in the string, and every time it hits a space, it basically is thinking, I just hit a space, there's a word that happened. So every time I hit a space, I just add 1. Word happened, word happened, word happened. We're not counting the words really, we're counting the spaces. Yeah. So it's just a clever little strategy. And then finally, what we're going to do is we're just going to return the count, and we're done. That's it. This is a very beautifully simple algorithm. Now, some of this takes a little bit of a leap of logic, and yes, people have done this work many times over. And there's libraries of these that, you know, people have done these exercises, you know, a million times. But it's always nice to kind of take a look at the logic that goes with it and why it works. So let's enter a string. Okay. Press enter. Is it right? 1, 2, 3, 4, 5, 6. Okay. Let's run it again. Let's try to break it. Let's put in question, 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 or question, question. Hey, there. Question, question. So this could be read as how many words? Yeah, we'll look up 4. So when this is confusing you, why, Cindy Lou? Oh, that's a separate issue.
It says my string function, it needs an argument.
We're now moving on to exercise 6.4, so let's go ahead and create a new program here. And you know, I'm thinking, well, let's create it first. So it's created. Let's do a save as. And here's my little conundrum that's going on in the back of my head right now. Look at this. It says, write list functions that carry out the following task for a list of integers. For each function, provide a test program. So is that creating a separate program for each one of these? Or do we put it all inside the same file? That's the way I read it too. So we're going to create a bunch of separate programs here. You guys ready? A lot of little programs. All right. So we're doing 6A first. So that's going to have an impact on how I name things. So I'm going to say, was it 6.4? Was that the exercise number?
Yeah.
6.4A. And you know what? And that's enough, honestly. All right. So with this one, the task is swap the first and last elements in the list. So this is a practice on lists. It's basically what we're doing here. So let me get my cheat sheet up on the screen here once again. Well, that's not how I did it. Last time I did them all in one program.
That's how I started writing it.
Yeah. It's a very long program. All right. So we're going to do this kind of simply here. Write list function for a list of integers for each function, provide a test program. All right. So here's what I did last time, and because I am copying from a previous solution, I started out with this. And I'll tell you what, for those of you that are here in the classroom, the benefit of being in the classroom, I'm just going to paste them here. So basically, I have 4 lists that are pre-created that we can draw from, and that way you don't have to type it in. So just go in there and copy those into your program just to have them. Okay, so those are we got one that's 1 through 10, one that's 1 through 9, one that's a mess of numbers, and one that has duplicated numbers in it. Okay. All right. I'm going to do the same thing we did before. I'm going to set up a main method. So I'm going to define it. All right. Then I'm just putting some junk in right now. And then at the very bottom, of course, I'm going to put a call into it so it actually executes. So from the main method, I'm just going to say, let's go ahead and just put the original list of integers on the screen. I'm going to say, here is the original list. So we're assuming we're working with the numbers 1 through 10 to start with. And all I have to do to put it on the screen, folks, is just call it. You guys notice I've missed my first double quote there. No wonder it's not all green. And I'm just going to say 1, 10. You know, not a bad idea to let's just run this and see what it does. Okay. Just puts the list on the screen. And notice how it puts it in square brackets and everything. All right, cool. All right. All right, the first task, where's my document? There it is. Swap the first and last elements in the list. So how do I do that? There's a command for it, right? All right, so here's what I did. First of all, from the main method, I created a variable and I stored the list. Okay, so I took the list, and notice I called the list command, the list method, so that it's treated as a list and stored in a variable. So now it's stored in the variable as a list. It's a separate copy. Then I'm calling a method that doesn't exist, and then afterwards I'm going to output the list that I put everything into with the stuff switched. So now we're going to go ahead and create that method. So what we're going to do at the bottom here is, outside the main method, we're going to start building all the individual functions that do the work. For the sake of time efficiency, I'm going to start pasting them in. I'll tell you right now, my machine feels like it's choking again. So here's the first method. So it's swap first and last. So what we're doing here is we're taking this data list, and we're grabbing the first position, position 0, and we're storing it in temporary variable. Then I'm going to take whatever is in position, and correct how I'm saying that, I'm going to take and look at that data thing and say, what's the length of my data, and subtract 1. Why am I subtracting 1?
To get the last character.
To look, exactly, right, because this would count 0 through 9, but I want the 10th position, right? So if I subtract 1, it puts me at 9. Okay, so the length is 10, subtracting 1, so we're grabbing position 9. So data position 9 is now being stored in the first position, right? And then whatever the last position is, and see the beauty of this syntax is I could have hard-coded a 9 in here. You know what? And if you did it that way, I totally accept it. I mean, it works, right? Provided that list never changes its size. What I did, though, is this allows you to change the size of that list, and it still works. Okay? And so we had grabbed the first number and put it into temp. Now temp goes into the last position. And believe it or not, we should be able to actually run this now and see the result. So you see how the first and last numbers were changed. Right. Next task is shift all the elements by 1 to the right and move the last element to the first position. So for example, 1, 4, 9, 16, 25 would be 25, 1, 4, 9, 16. All right, so let's do that work. Here's my code for the main method. Once again, we're taking the original list, putting it into data, and then we're going to call a new method that we haven't created yet, and then we're going to output it. So we need to create that method. And I don't know if this actually does what some IDEs do, like if they recognize that you have a method that you haven't created yet, they give you the option to create it with a right click, and apparently Spider is not one of those IDEs. So we're going to do that from scratch then. So this next method is going to be called shift right. So we're feeding in that list. We're going to take whatever's in the last position. You guys recognize that code now. So we're taking the length minus 1, whatever's in the last position, and we're putting it in a variable called last. Then we're going to run a loop, and we're going to say from position, the last position, to position 0. From the end of the array to the beginning, minus 1. So we're stepping through the array backwards. And we're counting down from 9 towards the beginning of the array. We're going to take wherever position that we're in, subtract 1, and take that and put it into the current one that we're in. Very simple. A very, very simple little algorithm. And then finally, we brute force take the one that we grabbed from the last position and put it into the first position, and we're all done. I will go ahead and run that. Now, did it work correctly? So we went from 1 through 10. Did everything shift right and the last one went to the first position? It sure did. As you guys are busily typing, I'm going to move on to the next one. Okay. So the next one is replace all even elements with 0. So here we go. I'm going to start with the main method here again. So I'm going to set up the mechanism for doing it. Now this might not be the way, the author may have done it all as separate programs, but I'm sure you can do it all in one. It doesn't really matter too much. All right, so it says replace all even elements with 0. Once again, we're taking the list, we're storing it in a temporary variable, and then we're sending it off to this new method that we haven't created yet, and then we're going to do the output. So we got to create one called replace even. All right, once again, I have that pre-created here, and I'm going to add that to my list of defined methods, and it's going to look like this. So now for this one, it says I is in the range of 0 to the length of the data. Now why am I not doing -1 there? Because Python does that for us automatically. Python is kind of a quirky programming language. In most other languages this would work. In fact, you would think that you have to go, you have to do this to bring it to position 9, but it automatically will not include the 10th. So this will actually work just fine. It will go from position 0 to 9. It'll never hit 10. That's why we don't have to say -1. Here we're going to say if whatever cell we're on, mod 2 equals 0. So if you do a mod 2, you're dividing by 2 and you have no remainder, that means it's an even number. That's how you figure it out. Then we're going to put 0 into that position. And we just run the loop until we're done. Okay. Let's run that one. So all the even numbers are replaced with zeros. We're good. I'm not responding right now, and I am recording. Okay. I was just trying to move the divider on my screen over. All right, next exercise is replace each element except the first and last by the larger of its two neighbors. Wow, that's a lot to think about right there.
That was one that I started to have troubles with.
Okay, let's take it one step at a time. All right. The first thing that we're going to do is I'm going to grab my code from the top section, so you can see kind of like what the output statements are going to look like. Right. Once again, we're grabbing that same list. We're going to create a new method and then display it. So that part is just kind of repeat over and over again. Now let's get that method in there for replace neighbors. And the beauty of this, like, you would think that this code, at least like my inclination when I think about problems like this sounds a lot more complicated, and it's going to have like 20 lines of code to do it, right? The truth is you can do it in just as few lines of code as all the others. In fact, isn't this fascinating? So let's take a look at it. It says for I in range from 1 to the length of data -1. Now we already determined that if we're counting up, it never hits the last one. So here we're saying that we are going from position 1 to 9, right? And we're not going up to 10, so we're not actually going to hit the last one. And we're omitting the first one, right? It says do that except the first and last. So we're not hitting the first and last numbers in the sequence. Those are going to be left alone. We're not touching them at all. Not even looking at them, right? As the loop operates for every number that we're looking at, and we're starting at the bottom of the list, or the front of the list, however you want to look at it, we're going to look at the maximum of the number that comes before, so the current position -1 and the current position +1. And see, this is where the max function is beautiful. I could write an if statement there too. Sure, right? You could come and do that with an if statement. Just grab those two values, see which one's bigger, right? And then if one of these is bigger, whichever one is bigger is going to go into that position.
Right.
So really simple little algorithm. That might not be intuitive. So did it work? Well, I guess you have to look. So 1 and 10 are left alone. So actually 1 and 10 are left alone. We go to 2, and it looks at the one before and the one after, and which one's bigger? 3 is bigger than 2. And so really what happens is we're just shifting all the numbers down, right? And so the result is pretty simple. And amazingly, the formula is pretty simple too.
Yeah. That was way simpler than when I was trying to do it.
Yeah. And there's a tendency here to overthink it.
Yeah.
But sometimes the algorithms are beautifully simple. Beautifully simple. Right. I'm doing part E. Remove the middle element if the list length is odd, or the middle two elements if the length is even. So this is going to require us, so you're wondering, why did we end up having, two different lists, like one's 1 through 10, one's 1 through 9? Well, it gives us that even and odd thing, so then we can check our results. So that's going to require some output changes as well. And this one is, okay, this bunch of code. So let's start with output first. All right, so now I'm pulling in both of those lists. One's going into data 1, one is going into data 2. Both of those are being independently passed to the method that we're about to create, and both of them will be output to the screen. Now we need to create that method. Remove middle. Remove middle is kind of interesting now. So this takes a little bit of thinking too, to see kind of the pattern. All right, so let's walk through this. First, we check to see if the length of whatever we're passing in is even or odd, right? So that's one of the stipulations here. So if we mod by 2 and the answer is 1, that means it's odd, right? Right, because we already determined if we mod by 2 and the answer is 0, we did that up here, we know it's even. But now we're checking to see if it's odd first, odd number in length. We're checking the length of data. If the length of data is odd, this is what that says. Then we are going to do a pop. Do you guys remember the push and pop commands? Yeah. I always like to think of them like this, because this is how I learned way back when. You go to like a buffet, right, and you get like, I don't know, I guess I don't eat at those places too. So I don't know, I can't name one. Can you think of like a buffet restaurant? You used to have like Ponderosa back in my day. Yeah, Old Country Buffet, thank you. And some of those places where they have their dishes, the dishes are put into these spring-loaded dish mechanisms, and you put the dishes in a stack, and as you put more dishes in, the stack goes into the cabinet. And when you add a dish to the stack of, you can think of it as a list, right? You're pushing it. When you remove from the list, you're popping it. Where are you popping it from? From the end of the list. So a pop command means that you're moving it off. How much are you moving? You're taking the length of the data. And what does a //2 mean?
That's
Floor division, which means what? We're looking for how many times it goes in, but not the remainder. It's like the flip of mod. And so we're looking to change the length to an even value. So if it's odd, we're going to change it to even. Isn't that what we're supposed to do? Move the middle element if the list is odd, or the middle 2 elements if the length is even. So here, our attempt is to remove the middle element. So by dividing by 2 and not considering the remainder, we're ending up in the middle position. Right? So if we have a list with a length of 5 and we divide by 2, we get what as an answer? 2. Right? Which in the list is 0, 1, 2. That's the middle position. See the cleverness of that? Otherwise, we're going to do this. We're going to pop, do the same thing again. We're removing an element. And then we're going to do the same thing again. We're still cutting it in half again, so we're just removing 2. We don't have to even determine if it's even because it already passed the test. So let's run this and see if that's true. After removing the middle element, is that right?
So 5 and 6 are gone.
Well, the first list is 1 through 10, so it got 5 and 6.
Yep.
The second one is the odd number one because it ends at 9, so it just got rid of 5. So it worked. Isn't that clever?
Yeah.
That's very clever. It also shows some practical usage for the float division, or the that form of division. What do they call that again? Floor division. Thank you. All right, let's move on to the next exercise. See if we can finish them all before the next class gets here. Move all the even elements to the front, otherwise preserving the order of the elements. Ooh, that sounds a little more complicated, right? Yeah, it does sound a little more complicated, but you know what? It's really not that hard to do. So here's our output piece that's going to drive it. All right, so we're pulling in the 1 through 10 list again, and then we're going to show the results, and we have this new method called even to front. This one does take slightly more code to accomplish it. So here's the result. So we bring in the structure. We set up these two variables. One is even position, we set it to 0, and another one is for position, which we also set to 0. And it's just kind of to keep track of where we need to put things. Then we set up a while loop, and we say, while the position is less than the length of data. Okay, so what's the length of data? What are we sending in? We're sending in 1 through 10. So the length is 10. So while 0 is less than 10, which also indicates that we must be changing that somewhere, we're going to start checking. We're going to say, whatever position we're currently in, if we mod by 2, is it even? So if that position, whatever's in there, whatever's in that position is an even value, then we're going to pull that one out, and then we're going to insert it into whatever position, even position, is currently set to, with whatever we pulled out of that position. So we're popping it out of its position, storing it in a temporary variable, and then inserting it into position 0 to start with. That's where it starts. The even position will get incremented then inside the if statement only if we find something even. Then the regular position will increment by 1. So now, if you think about what's happening here, is every time we find an even one, we're moving it to the front, and then we're keeping track of where we're at with that. So that's only going to increment if we change. The other one's always going to keep changing every time through the loop, and so functionally this will accomplish the task. So I'm going to go ahead and hit play. All the even ones are in front, in order, and all the odd ones are in the back, in order. Simple little algorithm. Very, very clever little math. These are, challenging from a logic standpoint too, and I always tell students, don't feel frustrated if you don't get the algorithm right away. Because I think sometimes the author of this book kind of makes the assumption that, people are taking this course over like 3 semesters or something, and they have all this time to talk about how the algorithms work. The reality is if you study computer science formally, what you'll find is that in many cases, in the intro-level program, they kind of give you what the answers are, right? Because you're going to sit there and try to figure out the algorithm. You might be there for months because you have no clue how to even proceed. And so in computer science class or studies, often when you get either to the tail end of your program or you move into the master's level, they'll start throwing at you a course called data structures, where they talk about all these algorithms, independent of language structure. It's all about how you think about how things sequence and how they work with each other. So I think it's kind of cool to know. Return the second largest element in the list. That's our next task. All right, so with that one, I'm going to add this here. And you notice I'm not even storing it in a temporary structure, right? Because you know why? I'm not changing the structure. That's the why. I just have to look. Now I need to create the method to go with it, which I have conveniently pre-coded here. Thank goodness, right? Had to type this all up by hand. What fun that would be. And then the algorithm looks like this. So for the second largest, and now notice that this data thing, right, we're just throwing in the pre-built list. And all we're doing is we're running the max function on the data. Right? Wait. Okay. So how do we get the second largest? So this is where the conundrum comes in. So we set up two variables, largest and second largest. And what we're doing here is first we find the biggest, right? That's important to know which the biggest one is before we find the second one. And so for that one, we're going to choose the smallest. But how do we determine what the smallest is? Well, that's where it gets a little more interesting. Okay, so it says for value in data. So it says for each one of the items that's in that list, we're going to check, so we run an if statement, if that value is greater than the second largest and the value is not the largest. So in other words, if I have already found the largest value, which max will do automatically, that's stored. If we find that number again, well, that's irrelevant, right? But we're looking for the value to be larger than that is larger than anything else we found, then that will be the one. But it's going to do that. It's going to keep looping through and checking that each time with each number until it finds it. I mean, it's really kind of a simplistic little algorithm. And then if you break it down and look at that list of numbers, your second largest value is 9. Is it correct? Yes. Look at what it did to the list, too. Well, wait a second. We didn't move anything around. It's not even looking at any of that, folks. It's only looking at the original list up here. It's not changing anything. All right. Let's move on. We still have 8 minutes before class starts. We got 3 exercises left. Okay. So return true if the list is currently stored in increasing order. Okay. Yeah, and you know what? That I think, in terms of the algorithm, I think you're right. It's probably one of the harder ones. It's logically, it's maybe a little bit more challenging to figure out. All right, so here's the output statements that I'm using. Notice that my divider's not. I was doing this before. Anyhow, it doesn't matter. Return true if the list is currently sorted in increasing order. So in order to test that, of course, I had to create one that wasn't, right? So I created one that is, so we're just going to call that in, and then one that isn't, okay? And then all it has to do is return true or false, right? Isn't that what it said? So the algorithm for doing that then is maybe a lot less code than maybe you would anticipate. Seems to be the case now, right? Right. So we send the data in, and it says for I in the range of 0 to the length of data minus 1. All right, so we're going to go from 0 up until the last position, second last position. We're going to check the value that we currently have to see if it's greater than the one next to it. If you find any value in the array, or the list, excuse me, that is smaller, or that happens to be bigger than the one that comes after it, it's not sorted correctly, so it just does a return false and you're done. All it has to do is find one of those and it's false. Otherwise, if it checks everything and everything is in order, it's fine. So it also explains why we don't go all the way to the end of the array, because we go to the second last position in the array and it looks at the next one beyond. We don't have to go to the last one. Right? Very simple little algorithm. Right? Yeah. Not really that complicated when you start to take a look at it. Right? The list is in increasing order. Original 1 through 10 is true. The messy list is false. Right? And remember, the messy list is this one, which I did on purpose. And that one will fail once it gets to here.